Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course for the Cisco Networking Academy. And in this afternoon's video tutorial, we're going to be taking a look at Discovery Activity 13 in our Cisco Learning Labs curriculum, where we need to configure OSPF stub areas, right? And when we take a look at challenge number 6, we're actually going to be doing some work with stub areas as well as totally stubby areas. So right now it wants us to take a look here on router 1, and so we're in privilege exec already, so we'll say show IP route OSPF, and you can see we have two external type 5 LSA routes here, a 198.51.100 and a 203.0.113. Now those are coming in as type 5s, so where do we think they're coming in from? Well, here on the outside of router 4, we've got these two routes. So if we were to take a look on router 4, if I were to say show run and pipe it to section OSPF, exactly, we've got a redistribute connected subnets command in there. So if I say show IP interface brief, there's our 198, and we should probably have show run interface. My guess is going to be Ethernet 01 is going to have an unnumbered or a secondary, right? So the secondary address, right, on this interface is also going to be advertised into OSPF. Again, because we're saying we want to redistribute connected subnets. And the reason we need that subnets command in there, or the subnets option in here, if we don't put this in here, it's only going to redistribute classful networks. So we put subnets in here to make sure that we get subnets that have been that are classless. Sorry about that. That are classless. Okay. So that's router 2, and actually we wanted us to look on router 2. It looks like. So let's take a look way over here on router 2, and we'll do the same thing. We're already in privilege exec. So show IP route OSPF, and again we still see those 2E2, the 20E2, the OSPF external type 2s. And again, remember, the default metric for an external, a type 5 LSA, is 20, right? And we saw this when we looked at, I can't remember the exact activity, but we took a look at the difference between E1 and E2. Remember, E2 is your hot potato, right? Hot potato routing. He doesn't care what the internal metrics are throughout this environment. He's basically just saying, you know what, here, my metric's 20, just get me out of this, get me out of the network to my external route as quickly as you can, right? Or to get to this external route for all the traffic as quick as you can, and the metric is 20. And so it's not accounting for any internal network costs that you may need to incur to get to the ASBR. Whereas the metric type E1 is going to take that into account. So let's go ahead and take a look here on router 1, right? So if we look at this, it's going to configure router 1 is going to configure area 1, which is the area it shares here with router 2, as a stub. And this makes complete sense, right? Because when we look at this picture, the question is, how many routes or how many paths does R2 have to get out of this area? It's got one path out. So it makes complete sense to say, you know what, we're going to go ahead and make this a stub, right? In fact, maybe we'll get to see what would happen if we make it a totally stubby area, right? Because again, this area here, there's not multiple ways out of this area. There's a single path out. So does router 2 need to take in, 50 different routes that give him more specific information on how to get to router 4 or maybe over here to router 3? No. He just needs a default route. He just needs to get to router 1, the ABR, and then router 1 can take care of everything else. So let's go ahead, let's configure router 2 as a stub router. And we're actually going to have to get on to router 1 as well. So here on router 1, we'll go into global config. I always like to do a do show run section OSPF to see what we have right now. So we've got the router ID, we've got our network statements there. So I'm just going to say router OSPF 1, and we're going to say area 1 stub. Now again, we're making this a stub area, not a totally stubby area. And you're going to see the difference here when we go take a look at router 2 in just 1 second. So now if I said show IP OSPF neighbor, you can see we're at 18 seconds, that dead time, right? It's the countdown to extinction, because I've changed the area type, right? I've made it a stub on router 1, but I never made that change here on router 2. So I'm going to let this die out. We're going to get a message telling us, yep, dead timer expired. The adjacency is down. Let's go ahead and get into global config, do show run section OSPF. All right, just like to take a quick look, router OSPF 1, and we're going to do the same command, right? It's simple, area 1 stub. So what this does, let's go back, let's scroll back up here a little bit. Let's take a look at our routing table. When I said show IP route OSPF, what did we have? And that is not what I wanted to highlight. So we had a setup here where we've got our OSPF inter-area routes, these OIAs, and we have the single, the two external routes, the 198.51 and the 203.0. Now we've made it a stub area, so let's see what we have now. So on router 2, if I were to say do show IP route OSPF, what do we have? Well, when we made it a stub, what we're saying is there will no longer be external. So, and that's actually, I don't want to get that out of there. Let's say there will no longer be OE anythings, right? There are not going to be external routes anymore. The only thing that the stub area is going to let in are going to be the type 3 LSAs, right? So you can see here we get that auto-magically originated default route, and then I'm still seeing all of these OIA routes here, these inter-area type 3 LSA routes. Now let's take a look at the database really quick. If I say do show IP OSPF database, you can see that the database is still showing all of these type 3s, right? Because we're a stub. We've got our type 1 LSAs here, the router LSAs. We've got our type 2s, and there is the link state ID, which identifies who? The DR. That is the interface IP address for the DR, and the advertising router is router 2. So, but again, we've made this area a stub, and so what it means to make an area a stub is it says I'm going to automatically originate a default route into the area, right? It's going to be a type 3, and I'm going to continue to allow type 3, other type 3 LSAs to also be flooded into the stub area. And let me peek ahead here real quick. Do they have us do a totally stub? There we go. All right, good. Area 2 stub, no summary. Good deal. All right, so this is a stub area, right? It gives us, automatically originates a default type 3 default route for us. That comes in, and we still get the type 3 LSAs. However, again, that conversation, do I need more specific routing information? If I'm router 2, do I need super specific routing information? No. I just need a default route to get to router 1. That's it. And then router 1 can deal with everything from there. That is my only path out. All right. So we've configured it as a stub, and we are not going to see any external routes, right? And let's see here. Once you configure area 1 on R2. All right, so examine the routing table. We did. Okay, well, let's check connectivity off of router 2, because it looks like we may have some issues here. So if I say do ping 192.0.2.1, right, so we're getting U's back in the ping output. And so, again, we don't have a specific route. We've got a default route to get us over there. However, the network is not being advertised any longer because it was an external type route. So if I say do show IP route 192. And what is that? 192.0. 0.2.2.1, it says network not in table. Now that's trying to take a look at the rib. What if I were to say do show IPsef for 192.0, whoops, .0.2.1. So just because you say, you look at the rib, right? So this is looking at the rib. And we don't have a route specifically for this network in the rib. However, when I look at the FIB, the forwarding information base, I do have a route. It's the default route, and the next hop is router 1, right? So the area border router, you can see they give a really nice description here, right? So you can't reach the 192.0.2.1. And the reason is because the network's not advertised in the OSPF domain as an external route. So despite the default route out to the stub area to the ABR is dropping traffic to that destination because it does not have a path to that destination. So the problem could be solved by advertising a default route from the ASBR router 4 into the OSPF domain. So let's clear the screen here. Let's take a look. So what they're saying is that router 1 is going to drop that traffic as the ABR, and let's see why. Do show IP route OSPF. So he's got an external route to get there, right? So what happens if I ping from router 2? Let's say ping 203.0.113.2. Whoops. So we have connectivity to that route because it's being flooded, and it says, it gives us a good little description here, it's being flooded as a type 5 LSA into the backbone area. So the first leg of reachability is provided by the default route injected into the stub area by the ABR. The second leg through the backbone is ensured by the existing external route. However, if we go back and take a look at this diagram, if I go back onto R1, do I have a route to the the 198.51? That is not the 192.0.1. So you can see we've got this type 5 that's being flooded, right? And so router 1 knows how to get here. However, router 1 does not know how to get to the 192.168, 192.0.2.1, which is this route, this route out here on the internet. I apologize. I was actually confusing myself thinking that it was this 198 here, but it's this route here. We can't get out here to 168 again, .0.2.1. We can't reach that internet route. However, I can get to the 203 because we have a type 5 LSA that gets flooded into area 0. So when the traffic takes the default route to router 1, the ABR says, he does a lookup in his table and says, yep, I've got a type 5 LSA that has information. It tells me how to get to this external route, and that's via router 4. And let's see what that looks like from router 1's perspective. So if I'm on router 1 and I say do show IPOSPF database, we're going to see, and that's what we want to see right there, is we have right here, here are the type 5 external link states, and this is actually for my interface in area 2. Let me scoot back up a little bit here. We're going to look in area 0, which should have been first. And summary network link states. Area 1, area 2. Yeah, so I don't see it in area 0 because it was originated in area 0. So it comes through though. So we'll look at it from this perspective here. So it does come through in area 2. It's seen, right? This type 5 LSA is being seen for these two routes. That's the route that we're able to ping, right? And how does he know how to get there? Router 1 knows because the advertising router is router 4. So router 1 does a recursion in the OSPF graph and says, do I know how to get to 4.4.4.4? If we scroll up Absolutely. I have a type 1 LSA that tells me exactly how to get to 4.4.4 or to 4.4.4.4. So everything works out great for that 203.0.113. However, it doesn't work out so great for that 192.0. And so we're going to solve this now. We're going to go ahead and do a default information originate statement on router 4. So we'll go into global config, do show run. Let me see if, let's include route. Do we have, and there it is. So we've got a static route statement already in the config for us that says the next hop is 198.51.100.2. So let's go into router OSPF 1. And that is the most common typing mistake for me, OSPF 1. And we're simply going to say default information originate. Now, I could use always, right? So if that default route went away, the IP route statement above, I would continue to advertise the route, but we can just simply say default information originate. Now, if I go back over to router 2 in area 1, and we try to ping that address now of the 192.0.2.1, we have full connectivity. In fact, let's see, do I still have my default route? Do show IP route OSPF, and I do. It's a type 3. Let's come into router 1 here and see do show IP route. And now I have, whoops, router 1 also has a default route telling them to go to router 4. And wait a second, Ethernet 00. Let me double check that. Yeah, okay. Okay, the IP addressing is a little odd here. So 172.16.14, so this is going to probably be .1. I would have said .4 here, but it looks like they're using .2. So let's confirm that. Do show IP interface brief. And yeah, so the Ethernet 0 interface on router 4 is 14.2. So that is my default route on router 1. So now router 1 knows where to send that traffic to stitch it over to router 4, and then router 4 will take care of the traffic from there on out via that default route. So on the ABR router 1, it says examine the injected default route, and we just did, right? So here's our default route, and we took a look. We already saw the link state database. We've got full connectivity. So connectivity is working. So now what we're going to do is area 2, right? So this is going to wrap up our activity here. So area 2, we're going to go ahead and make that a totally stubby area, right? So on router 1's Ethernet 02 interface, we'll come over here and we're going to say, or not actually not on the interface, we're going to say area 2, and we're going to make this a stub, but we're going to add in the no summary keyword. Now remember, router 1 is the ABR here. So it's the area border router. So it's at the border where I need to indicate that this is a stub no summary, because this is where it's going to squash not only the external type 5 LSAs, but any inter-area type 3 LSAs that try to come through. So I have to have the no summary keyword here, right? So now the dead timer is going to count down. I'll scramble over to router 3, and we actually have not logged on to router 3 yet. Show IP OSPF neighbor, and we're going to see exactly what we would expect. That countdown to extinction here, it's definitely going to drop below 20. And it's going to continue all the way down. So we're going to catch it before, hopefully. Do show run section OSPF. And it looks good there. So we'll say router OSPF 1. And I'm going to say area 2 stub. Now, here I don't have to say no summary, because that's already being done for me, right, by the ABR. Now, if I were to say no summary, this isn't going to break anything. However, it's kind of the difference between, I like to use the analogy that this is like the difference between when someone asks you, hey, how are you doing? And you say, I'm doing good, right? Well, the proper way to say it is actually, I'm doing well. So if I were to say stub, no summary, this would be like responding, yeah, I'm doing good, right? If I pull that off and just put area 2 stub, this is the equivalent of saying I'm doing well. So this is really the proper way to do it, because again, router 3 is not an ABR. It doesn't need to indicate that it's a stub with no summary. That's already being done at the ABR router 1. So now on router 3, if I say do show IP route OSPF, let's see what we've got. That is all we get. So this is a totally stubby area, right? Totally stubby area. No type 5s are allowed in, and no type 3s are allowed in, with the exception of who? You've got it. With the single exception of the default route that I get from router 1. And so really, when you look at it, if we clear the screen here, oops, and we go back, really when you look at it, it doesn't make sense to leave this as just a stub. So this is probably the approach I would take, as I would say totally stub here. All he needs is a default route. And then same thing here, totally stub, because again, router 2 can only get out that way. Router 3, same thing. All their traffic has to go to router 1. So there's no reason for me to have all of these type 3 LSA inter-area routes flooding into these areas, providing me with more specific routing information, because it's irrelevant, right? 3 has to go to router 1. Make them a total stub. 2 has to go through router 1 to get out here, or to get to the internet, or get anywhere. So just make it a totally stub. Now, the reason that they made area 1 a stub, right, is because they want to show you the 2 different ways to do it. But again, in the real world, if this is your setup, and 2 has to go through 1 and 3 has to go through 1, make them totally stubs. Throw a default route in there. It's not going to matter, right? In fact, it's probably going to save you a lot of grief when you're looking at the routing tables on 2 and on 3, as well as the OSPF databases, because they're going to be extremely efficient. So do show IP OSPF database. I mean, take a look at that OSPF database right there. And let's compare router 3 to router 2. Do show IP OSPF database, because remember, we made router 2 just a stub, not totally stub. So again, we've got all of that there as opposed to just that, right? All right, and so that is pretty much it. And I like the way they refer to them as leaf routers, right? Router 2 and router 3 are leaf routers. And it's the ABR who's doing the blocking. So that's why the ABR needs to know, is it stub or is it stub no summary? But again, that keyword has no effect on a leaf router like R2 and R3. So again, you could put it there if you wanted to make it easier to troubleshoot, right? If you were to, to take a look at it, maybe somebody not familiar with OSPF would say, oh, okay, stub no summary, that must mean that this guy is in a totally stub area, right? However, the proper way to do it, since it doesn't have any effect, is to simply leave it off of there. And in fact, did we do show run? Let me see here. Pipe it to section OSPF. Does it actually even put it? Let's say area 2 stub no summary. Let me see if it actually even puts it in there. Yeah, okay, so it does put it in there, right? But again, to somebody who knows OSPF that takes a look at this, they may stop and pause and say, wait a minute, is this an ABR? Because that's where you would put that statement. So again, either way it will work. It's going to function, right? But really the proper way to do it is on a leaf router is to not put that no summary statement, because it's really not needed. All right, well, this wraps up all of the challenge, discovery, and lab activities for week number 4. And boy, we had quite a bit to do with OSPF. So this is it for taking a look at the stub areas. Again, we haven't taken a look yet at the not so stubby area, the NSSA, where we'd be dealing with type 7s and they'd be getting translated to type 5s. I'm not sure if we do or not. That definitely moves you into an CCIE area there when we start to talk about NSSAs and totally NSSAs. All right. Thank you guys so much for watching. I hope that this has, moved your studies along and kind of clarified things for you. I know we have a lot more time here in the video sessions because we're not limited to that, that couple of hours that we have once a week before I get you onto the lab equipment. So again, any questions, please contact me and enjoy what's left of the rest of your weekend. And I will see you guys tomorrow night at 6 o'clock.